Good afternoon, everyone. Welcome to today's webinar, and thank you for joining us. My name is Patrick O'Brien. I'm Director of Product Management at aPriori. I'm pleased to be joined today by Julie Driscoll, who's our Chief Product Officer, Steve Peck, who's VP of our Sales Engineering Group, and Samantha Escaglione, who's our newest member of Product Management team at aPriori. So we're all very excited to talk to you about aPriori's newest product offering, Cost Insight Generate. We have a lot to cover, so let's get started. Julie, I'll pass it over to you.
Thank you, Pat. Welcome, everyone. Thanks for joining us. So I'm going to kick it off with a quick introduction of Cost Insight Generate and talk a little bit about the motivation behind the solution that we've created and the problems that's addressing. Then I'm going to turn it over to Steve, who's going to do a demo of the solution and show you the product live. And then Samantha is going to talk about what's going on under the covers and how Cost Insight Generate is deployed and set up in your environment so that it can be used on a continuous basis. And then we'll wrap up with some Q&A. So the motivation behind Cost Insight Generate, it was built to address the challenges we were hearing from our customers on time pressure in product development and the pressure on time to market, lowering product costs, engineering bandwidth constraints, and concern about asking engineers to do one more thing. And that they were having capacity issues, but at the same time, the cost engineering team didn't necessarily have the bandwidth to expand the components that they're analyzing. And so was there a way that we could put more automation in our analysis so we could help streamline the process, be more efficient, and be serving up guidance to the constituents within the engineering process? Concern was based on the challenges that late stage information was causing ECOs to occur, having products get called out late in the cycle for manufacturability issues, impacting product launches and cost targets and product margins. On top of sort of the typical challenges we're faced now with the COVID-19 situation and the pandemic, which is very likely causing either demand, workflow, supply chain disruption in your organization, or a combination of all of those things, and you're being pressed to make decisions very quickly, maybe go, no-go decisions. So it could be that your product development initiatives have tailed off, but there may be other applications of where Cost Insight Generate may be applicable, and we're going to talk more about that. While we did focus initially on use cases for product development, there are applications in value engineering and in sourcing where the integration and automated analysis can be helpful to looking very quickly at a population of parts and focusing on those with the biggest issues. So imagine a different world where rather than analyzing each part in front of a UI, what if you could automatically analyze a part at a trigger? Maybe it's saved into PLM, and has a certain status. And with that automated analysis, you can identify the parts that have the most manufacturability and cost issues so that you can go very quickly from a population of components down to a short list and then dig into those short list items for looking at more detail about the cost drivers and the manufacturability guidance to drive an improved design or an improved sourcing decision. And what if you could get this information automated to the right people at the right time? Well, that's what Cost Insight Generate is all about. It's really changing the paradigm of which you interact with and generate the initial analysis and get information to drive decision making. So Cost Insight Generate is built on our existing cloud solution. So it takes advantage of all of the capabilities that you've been using, whether it be on-prem or in the cloud, things like our automated cost models, our ability to pull geometry and product information and tolerances from the CAD model to use in costing, including our breadth of manufacturing cost models, regional data libraries, the DFM guidance that we're producing in an analysis, the reporting, and our automated analysis. But there's three key areas that we want to highlight today, which add to our overall solution. One is around PLM integration. We're making it much easier to connect with your PLM system and pull in information that can be used in an analysis, as well as push information out to the PLM system. The second is defining automated analysis and creating and setting up workflows so that automated analysis is going on almost under the covers to support a process. And then third, proactive notifications. Being able to push information to a user base rather than having them have to interact and cost each part on their own. And a lot of our solution here came from feedback from the engineering community of, I really like the DTC and DFM information that you're producing. I'd rather you tell me which parts need a closer look. So if you think about the opportunities from the range of constituents who are involved in a product development project, design engineers can now design and validate simultaneously and then get input on those parts that need a deeper look in helping to optimize those designs and ultimately reducing getting called out later and having a late stage ECO for a manufacturability issue. Cost engineers have the opportunity to streamline the process and focus on the items with the biggest issues and being able to more faster analysis and faster response so that they can look at parts, but also let the automated analysis run for those that they don't need to dive into as deep, but that feedback can go to the design engineer. And using a combination of Cost Insight Generate and Cost Insight Design, they can send a URL to a design engineer for a specific component, and they can point out the issues and the guidance that they want the design engineer to take a look at. So from a team leader perspective, able to analyze more components in the product, not only initially, but also as they evolve to mitigate product risks. And this early information can be available for product managers to roll up the data to look at decision-making around maybe a price point or ability to meet a margin target, getting information to inform the roadmap. So imagine a workflow, and I'm going to set up a workflow, and then I'm going to turn it over to Steve to demo, where your design engineer is working in CAD and they check a part into PLM. There's a trigger which initiates an analysis automatically in aPriori. That analysis is executed, saved in the aPriori database, can also be pushed back to PLM. Can also be pushed to the design engineer so they can get some guidance on parts that need further attention. This solution has been set up with flexible workflows. As we've worked with customers and collaborated with our user council, we've seen some different workflows that would be implemented based on different companies' operations. We have seen that some companies would want the notifications to initially go to the cost engineers, have the cost engineers validate and refine the analysis, and then push only those items to and components to the design engineer where they validated that there's an opportunity to address an issue which could improve manufacturability or reduce cost. But from these notifications, you're able to then go right into the product. So there is a link which takes you right into the product and right into the part in question where you're getting that guidance. So you can then open it up and get visual feedback relative to the initial high-level feedback that you're getting through the notification. So Cost Insight Generate is going to be generally available in our software release at the end of May. And then we also will be incorporating this into our roadmap ongoing and continuing to make enhancements to it like we do with aPriori Professional and our other cloud applications. So at that, I'm going to turn it over to Steve, who's going to show you the product live.
Thanks, Julie, and hello, everyone. So I'm going to pick this up from the point of all the processing has been done behind the scenes on the PLM side, and I'm a design engineer coming in for my day's work. And within Outlook here, I have an email that showed up, and this is a summary of the parts that I've worked on most recently. In this case here, parts that I worked on yesterday, made some tweaks to, modifications, just to continue to evolve the designs on those. And what this is showing me is a report of those different parts, some stock machine parts, some sheet metal parts that I worked on yesterday. And it's identifying the parts that are of the highest risk for manufacturability issues. So those parts with some features in them that are causing problems, are non-manufacturable or going to drive cost of the part up significantly. We can see where that fully burdened cost estimate is currently at, and an indication as to the results of the simulation. If there were some parts that did not process completely for one reason or another, I'd be alerted to those. In this case here, all the parts processed, through the automated PLM process successfully. But what I'm really interested in here is this part, that stock machine part that is flagged as a high DTC risk. If I wanted to get additional information on that part as to what is driving that, this has been configured to automatically attach a report with summary information on that part. So I can dig into that part and take a quick look here at the component. We can see a thumbnail. This is a machined frame, an aluminum frame, part of an airframe structure. There's a couple hundred of them being built a year. It's you can see here the DFM risk rating is high. The stock is getting cut on a bandsaw and then to a 3-axis mill. I have some cost summary information in terms of the original target, which was $550 on this. The current estimate has it at $585. The initial quotes coming back from suppliers, the initial quote was at $700 here. So there's obviously some cost reduction work that's required to drive this down in terms of aligning with targets, but also, I probably want to gather some details to have a good discussion with the supplier in terms of, the results of the current quote that's coming. I can see that this is pretty, over the life of this part, it's close to $600,000 spend on it. But really the key information that I want to take a look at here is the information that's leading to that part being flagged as a high risk from a DFM standpoint. So this has given me a summary of some of the manufacturability issues. I can see there's 7 issues with this part, of which there, sharp corner issues are being flagged that I may need to address. There's some slow operations in terms of contouring on the part that, could potentially be optimized with some changes. There's also flags here indicating any holes that may be non-standard that would drive additional tooling requirements or any non-standard fillets. So some summary information being presented in a quick report where I can digest this information and understand just why this part is being flagged as having a high DTC rating. If I wanted to dig in deeper, I could click on the link directly from this report here. This report could also have been attached directly to the record in PLM for this part. So you come in to work in the morning and all of your parts have been processed in the background, and a report for each of those components automatically attached so that you can get a quick view and get to the information that you need. In this case here, I can drill into Cost Insight Design either through the report or directly from any of the links within the email. So let me go ahead and look at this part here that's been flagged as having a high DTC score. So I'm running Cost Insight Design in the cloud here. All of the information that's being authored is, available in real time to enable collaboration and easy access. I'm sitting actually in my living room right now, and it's pretty easy to get to log out to a browser and get access to this information. And share it with other colleagues, whether through reports or maybe aPriori professional. So within the viewing environment here, we have pretty typical tools that any CAD designer is used to in terms of being able to navigate through a part or an assembly, look at information like, some basic measurement information. This is just over 60 inches long, 3 3¼ inches in terms of the frame size on this part. Any information I want to gather on a particular feature, I can quickly identify and drill into information on right down to the feature level. So for this hole, it's just under 1/4 inch in diameter. It's taken 5.6 seconds to drill. So any feature and geometric cost driver that's been analyzed on the part can quickly be interrogated with the application. We can look at maybe you want to, you have a complicated part, you want to look at a cross section on the part. I can simply drag a slider plane and section through the part to be able to get a view of the internals as required. If this was an assembly, I could go in and create an exploded view. So some tools that allow you to quickly understand the design that you're looking at and the different features of the product. On the left side here, the interface is set up to be able to quickly interrogate and understand the results here. So this is a stock machine part simulated in the US with an annual volume of 200 parts over the course of 5 years. We can see the 6061 aluminum material, and on any of these areas, I can dig in deeper. So here I can see, the cost per pound that's used in the calculation here. We can see the information about the stock that's been used in the analysis and the manufacturing simulation for this part. So presenting the details at the appropriate level, you can drill into, cost results, for example, and I see a nice graph of, how that cost is broken down. 37% of it in material, labor at just under 20%, direct overhead at 13.4, all of which is summing up to a fully burdened cost of this part in its current state at $412. What I'm really interested though in is digging into the details of why this part was flagged as having a high DFM score and some manufacturability issues. So I can jump directly to the design guidance, and this will now point me to the exact areas on the parts where I have some issues. So this is the area where I have sharp corners that have been identified. So I can see this vertical edge of the part where it's a sharp corner, quite likely not intentional. That would be pretty costly. I'd have to go in and burn that out, or go in with an additional setup to be able to manufacture that, if that truly was part of the design intent. Otherwise, it's a manufacturability issue. It's going to cause big problems, if this part was released in this state when it went to get programmed and ultimately manufactured. I can see there's some contoured surfaces identified. Those are actually just breaking the sharp on the part there. So those are actually intentional. They are slowing, they do require some contouring, but not a big deal. And then I have some contoured milled corners across the part here. That's really the result of the filleting strategy that's been selected on the base of this part here. I can see the sharp corners where I'd have to go in with a small tool and be able to cut that out if I truly required that geometry on this part. In this case here, taking a look at it and being alerted to it, I realize that that is not really the design intent, nor is that critical from a form fit function on this part. Additional information here in terms of some color-coded set information that you can see here gives a really quick display of issues and cost drivers on the part. So here we're looking at areas in red where they have the slowest cycle time. If I had tolerance information and tolerances that were driving subsequent manufacturing processes such as grinding, I'd be alerted to those. So a quick view of really the issues in the parts of the design that are raising some concerns about manufacturability. So I've actually gone through and made the changes in CAD to this design. So there's a plugin that allows you to work concurrently between your CAD design, make changes from a geometric standpoint, a PMI standpoint, and so those reflected and updated within Cost Insight Design. I'm going to just jump to the end results where I've already made those changes to clean up and address those issues, and we can take a look at the result there. So I'll actually filter down my list of parts in Cost Insight Design here and open up the R2 version of this part. So here we can see as this part opens, you'll see that the geometry has been cleaned up, the The radii at the base of this part have all been cleaned up, so it's a nice smooth round, small radius where the ball end can travel around successfully. That sharp corner that we had on the vertical edge has been addressed. So we've made changes to get rid of the contoured corners, the sharp edges, and those types of issues there. If we go to our design guidance now on the revised version, we can see that those issues have been resolved. All it remains is the intentional contouring on the corners there for the part. So in doing that, I believe the cost was $412 before, dropped it down to $351 for a fully burdened cost. But more importantly, we're really catching these issues before design release and without really having done much, since all the processing was done in the background upon check-in to PLM, and then the notification pointing me directly to the part that I needed to be concerned with. So if I go in and want to line these parts up to truly see, the before and after state, I can create a quick cost comparison here. I'll just make it R1 versus R2. And what we'll do is add the scenarios. So we have that part number. Again, we can filter down based on various criteria. I have that 550 part number. I'll just pick that and look at R1 versus R2 here. And what we can see is a summary where we have our starting design on the left and then the modified version on the right column. The last column is giving us a summary as to whether we've moved in the right direction or not. So one important piece, this is an airframe component, a frame. Obviously, weight is critical. I've moved in the right direction there by modifying the radius at the bottom of all those edges there of the flange. I've actually reduced the radius, removed a little bit of material, still structurally acceptable, but this is kind of an added bonus of pulling a couple % out of the weight of the part. I've also had a pretty significant impact to the cycle time. So eliminating those sharp corners and the slow operations, I've been able to take 25% out of the cycle time to make this part. And in terms of cost, we've dropped it from $412 to $351. So we've taken just under 15% out of cost by eliminating those issues and optimizing this part for manufacturability, all based on this low effort behind the scenes analysis that went on. So in terms of the work that I had to do from a designer standpoint, it was more about interrogating the design, using that information to adjust my design and make the appropriate changes. So that's one example workflow where it's direct feedback pointed towards the design engineer responsible for a particular part. Now, it's just one example workflow. This could also generate a report that would provide a link to a cost insight report. Maybe in this case here, it's the design manager overseeing the structural machined parts on this structure. So this could be a link directly to this report, which is a cost versus mass report with identification of all the parts within the design community that are stock machined and where they stand in terms of a couple of aspects, one being their manufacturability and the other being their annual spend. So the color coding indicates the manufacturability. So the light blue indicates no DTC score, the orange being medium, and the ones with the dark blue having a high DTC score. So this part here is the one that we just reviewed. It's an outlier in terms of the manufacturability issues. The size of the bubble is actually indicating the annual spend. So there's $117,000 annually on this part. If you wanted to dig into any of these parts, you can drill further, but this is kind of providing a comprehensive view over the entire team. And this could be a daily notification going off to the structures manager. He could dig in, look at the parts and say, hey, this one, I know complicated, the manufacturability issues, there's a lot of content going on this part, but that's really required for your designer to have a second look, or definitely some opportunities there. So a quick view of getting to the right information based on your user role. So within this workflow, there's the design engineer, but you have others in the organization, the cost engineer, for example, or maybe the procurement specialist, where within the cost insight, the role-based design environment, although it provides the right level of detail for the designer, maybe others in the organization that need to drill deeper. So maybe the cost engineer is still working with an aPriori professional. So the one thing to note is that these applications are all running, so they're all running in the cloud, and they're all accessing a common operational database for all the costing information and costing events that are happening. So that means that within aPriori Professional, I could go in and search for a given part, and that part is the one that we were just looking at, the 550 R2 part. That actually is up to date, real time, so that within the different applications, you can access this and know that your definition is up to date. So if now I put myself in the position of a sourcing professional that really wants to analyze things that are beyond the designer's scope, in terms of looking at things like, well, what if we vary batch size on the part, or maybe there's an alternate routing that we want to analyze. So the sourcing professional maybe will want to look at alternate suppliers. We've got a problem with a supplier. Let's look at based on a virtual production environment mimicking another supplier's capabilities. Let's see how that results. So in this case here, maybe we have a supplier that only has a 5-axis mill available, but at least they can make the part for us. So I could go through those alternatives and understand the impact. It may not be that it may be a more expensive option. At least I'll be able to understand it, and maybe I can make a wise decision that, hey, just to get this made, I'm going to have an alternate supplier here. But in this case here, we'll run it with the 3-axis. Maybe we see that, hey, the designer actually didn't include the secondary operations here. We need to have a type 1 anodize on this part. We can go in and add any sort of secondaries, and the batch size right now, it's assumed that we're running this monthly. Let's go down to quarterly. Maybe it's more efficient, and suppliers are having a hard time keeping up. Let's reduce the burden a little bit there and be able to simulate the results here. This could go down to detailed machine levels and alternate suppliers and virtual production environments. Information that really the sourcing or a cost engineer would know, but not necessarily the designer. But they can also collaborate effectively as well. So there's a capability in the application. It's a cross capability function that allows you to capture notes, and these would be available within CI Design or within AP Pro. So we could put in a few notes here, added anodizing, updated batch to 50, etc. So you could capture notes and then be able to see that, since we're all working on a common database. So here we've run the changes. We can see that with the reduced batch setups and the efficiency gained by going to the quarterly batches, as well as even including the anodizing and the offsets there, we've further refined the results. It looks like a little bit of additional reduction has been added as a result of this. But the idea is to really allow this collaboration within the overall solution set, using the application that makes the most sense based on the role that you have. But all of it really initially triggered by automation in the background and the processing of the data through PLM. Another example may be a report that goes to, in this case here, this is a summary report looking at the different projects, assemblies that are being designed currently from an NPI standpoint and where they stand relative to target. So I can see one's, way over at 111. There may be a decision to actually can that. There may be some others here that will continue. Another one here, this one that's at 20% over. Maybe based on the market conditions, it's a desirable product to continue with, but you want to get a view as to why that may be. So here is a summary report we can drill into, and you can see the 4 different projects. This is the one that was 111% over target. Where original target was $31 on this, and it's now at 65. So these are regulators, water flow metering company example here. So these other 2 projects in the second and fourth column, they're tracking relatively close to target. Should be able to get those released and continue with those. This one here, this was original target at 1852, but now at 2352. So maybe you want to drill in further, right? So the program manager responsible for that, trying to decide, hey, is this feasible to bring back in line? We know that there's market for it, but if we release it like this, we're never going to hit margins. We're going to lose money on it. So let's drill in a little bit. And now you can start to go a little bit further, right? We can see that there's one part within this overall assembly that's really the causing the problem here. So this is the cage billet for the spring cage on this regulator assembly. So we could further dig in to this part, understand and look at alternatives. Maybe there's an alternative to die cast this, or other materials. But the idea is to really present you with the most relevant information to take action and focus in to be able to, ultimately make data-driven decisions based on information that's generated automatically for you and presented, so you kind of find that needle in the haystack without having to dig around for it. So with that said, I'm going to turn it over to Samantha, and she'll talk a little bit about how this is all coming together in the back end and the integration with PLM.
Great, thank you, Steve, and good afternoon, everyone. In what Steve just showed, you got a glimpse of how end users might interact with CIG, leveraging some familiar applications like CI Report and CI Design, along with some new functionality like those email notifications that Steve showed. Now, I'm going to take you through this diagram behind the scenes of CI Generate to give you a quick overview of how everything you just saw in the demonstration fits into our overall solution. Then I will focus on our newest module, Cost Insight Connect, and specifically how it's used to set up automation to cost parts and push out results. This slide is meant to show the way the data flows and the way the system is deployed. There are a lot of new things, specifically on the left side of this screen. So to start, you'll see that we have something called the aPriori agent on the left-hand side. This agent sits between the PLM system and CI Connect to handle reads and writes. The agent is a small piece of code that's installed in the same environment as your PLM server, and it runs as a service, allowing CI Connect to both leverage data within your PLM system and author important data back to the PLM. As we move to the right of the agent, you can see Cost Insight Connect. So this application is where all the setup for automated workflows and integration with the PLM system occurs. It's within CI Connect that you can configure notifications and reports like the ones you just saw in the demonstration. So as I mentioned, we will be diving deeper into CI Connect in the next few slides. But as we look to the right, we can see that CI Generate is a solution that leverages, as Julie mentioned before, a lot of our existing capabilities and products. To drive CI Connect, we built some new services that use the same underlying costing engine and reporting engine as CID and CIR, but instead of the user interface of the products that Steve was showing, these services call the same code in a headless automated fashion. So we have the reporting service to generate and configure reports, the export service, which is how you move data from the operational database to the reporting database, the insight service to cost and analyze parts and interact with CI design, and a new notification service, which is how we send out emails like the ones you just saw. So now, as you can see by the title on the right-hand side of the screen, everything here on the right side is in our aPriori cloud. So when we surveyed our user council, we found that a little over 80% of respondents' companies were considering cloud adoption. CI Generate is currently a cloud-only solution, and we'd like to get your feedback on your company's plans for cloud adoption. So please take a moment to answer the polling question that you should see on your GoToWebinar screen.
Okay, so it looks like we have about a quarter of the respondents saying yes, and another 44% saying maybe 10% not pursuing the cloud. Interesting. I think that's pretty consistent, maybe a few more on the not sure side, but pretty consistent to what we're seeing from our morning poll as well. Back to you, Samantha.
Great, thank you, Julie. So now that we've gone through this on a high level, let's dive into CI Connect and start by talking about how we define the automated process. So the first step in a CI Connect deployment is integrating with your PLM system. Once you install the agent that we mentioned a little bit earlier and establish a connection between Cost Insight Connect and your PLM, you can use this connection to define queries that pull a set of parts from your PLM system to be analyzed. The next step is to define a workflow. In CI Connect, you can think of a workflow as a definition for automation. So a workflow can read information from your PLM, cost a set of components, create reports, notify users, and write information or attach reports back to your PLM. It executes all of these things on an automated schedule that you set. You can also monitor currently executing or previously executed workflow instances, and you can view details for a specific workflow instance at a more granular part-by-part level directly within CI Connect. For all of this aggregate workflow result information, you can export the details in CSV format for further analysis. Once you're done defining the workflows, you can go ahead and generate results. And in setting up a workflow, you can choose to generate a report, send email notifications, and/or write back to the PLM system. As Steve showed in his demo a little earlier, all of these CIG generated results are actionable. The email and report both include links to CI design for deeper investigation, but they also provide meaningful information to their recipients before that extra click. So now that we've gone through all of these steps, we'll go through each of them in a little more detail to give you a better idea of how they're put into practice within CIC. So in terms of integration with the PLM system, the first step is to create a connector. A connector is CI Connect lingo for an instance or view into a connection with your PLM system. The second step is one we touched on earlier. It's the installation of the aPriori agent to manage communication between the connector and your PLM system. To facilitate this communication, CI Connect generates connection information that you can import to the agent during setup. It's important to note that agents and connectors are mapped one-to-one, and the connection info makes sure that they're pointed at one another to communicate effectively. Once the setup is complete and the agents are able to effectively communicate, CI Connect is ready to execute workflows. Now, when we gave an early preview to the user council, we launched a survey and found that a little over 90% of respondents' companies were on either Windchill or Teamcenter PLM systems. So we have been prioritizing Windchill and Teamcenter throughout development. We'd love to hear from you on what PLM systems your companies use, so we could prioritize those systems for integration going forward. So please take a minute to answer the poll that should be on your screen.
Okay, so here we do have Windchill and Teamcenter as the primary PLM systems, and then a tie for Innovia and SAP PLM. So we're tracking closely to our roadmap. Our next component, our next system is planned to be Innovia, but we'll be looking very closely with demand. Be interesting to know what those others are. We hadn't seen 33% of other in any of our surveys. So if you are on the call and you want to send us at some point a quick note or in the chat to put in your PLM system, we'd appreciate that feedback. Thanks, back to you.
Thank you. So now moving on to defining workflows, we can start by setting up workflow details. So when you set up workflow details, you can give your workflow a name, a description, and associate it with a connector to link to your PLM system. You can also choose a schedule over which it will execute. For example, you could set up your workflow to execute once a week, every Friday at 5 p.m. If you would rather run one costing event than keep the workflow on an automated schedule, CIC does allow you to disable the schedule and manually invoke the workflow. Once details are set up, you can create a query. So based on the PLM fields that you map in during connector setup, you can craft query statements to extract the set of parts that you want to process in your workflow. For example, you could look for all parts checked into the PLM system within the past week. After setting up your query, you can move on to costing inputs. And costing inputs is a really important step, because this is the step in which you define where production inputs, admin info, and UDAs should pull their values from. For mapped fields, you can pull values directly from the PLM system. You can also manually set a constant value, either as a default for when the PLM system is blank, or as an override to be used for every component. These values can also be pulled from previously established PMI attribute mapping, VPE defaults, or even costing service settings, which are default settings configured in CI Connect to be applied in any workflow regardless of associated connector. So once you're satisfied with costing inputs and overrides, you can configure your output actions. And as I mentioned before, CIC allows for 3 output actions. The first is reporting. As Steve showed earlier, the DTC part summary report shows important metrics related to costs, material usage, and manufacturing issues. This report also contains a link to open its respective parts directly in Cost Insight Design for further detail. The second action is email notification. These notifications highlight manufacturability through DFM risk rating, and they can be configured at the workflow level to be sent to key stakeholders in your organization. Similar to the report, this email also contains a link to open its respective parts directly in Cost Insight Design for further investigation. The last action is PLM Write, and this action really epitomizes the solution's integration with the PLM system. So for PLM Write, you can select fields to write back to part attributes in your PLM system and attach generated reports back to parts. Your engineering team already spends most of their day in CAD and PLM systems, so now you can communicate aPriori's valuable insights to them without disrupting their work stream. So with CIC actions, you're not just getting the right information to the right people at the right time, you're also getting it to them in the right environment. So with that, I'll turn it back over to Pat.
Thank you, Samantha. So if you think about applying Cost Insight Generate in your business, I think we focused on today was supporting the design engineering team with early visibility into manufacturing guidance and NPI projects. And that really was the impetus for kicking off the CI Generate project in the first place. But during the presentation, today we were focused on the design engineer, the workflow, how CI Generate can really help get that early visibility into manufacturing guidance. We've been in discussions with several customers. We're really realizing that this whole process of automated costing can work very well for other use cases as well. So, for example, value engineering projects, they're great candidates. You might have a cost down project focused on a particular function or component of an existing product, for example. And within your PLM system, something like Windchill Teamcenter, you might create a project that contains a bunch of parts that, hundreds to thousands that really are involved in the rework of some pieces of an existing product. And what you want to start with is costing those parts so that you can perform either a should cost versus known cost kind of analysis on those parts using reporting once they're cost, or look for outliners by looking at for sort of the DFM risk ratings to see which parts might benefit from a redesign in the vein that Steve was showing earlier. And similarly in sourcing, they can also benefit from an automated costing, supporting like quote analysis and should cost negotiations with suppliers. So you could take all the parts in a bid package, automatically cost those, and make them available for procurement personnel to use during their negotiations. So we think CIG can certainly be effective in a broad set of use cases within your organizations. And that leads us into our last polling question, where we'd like you to tell us which of these use cases, the 3 use cases here, do you think would provide the biggest benefit for your company if you're using CI Generate? So your answers will, as Julie mentioned before, help drive requirements for CI Generate going forward. So if you want to start your polling now. Great. Julie, any comments on that compared to?
This is very consistent with what we were seeing earlier this morning, that NPI is about 1/3 of the response, but there's also quite a bit of thinking of sourcing would be the place to start in the current environment. We saw something similar this morning as well.
That's great. Okay, I have a couple of questions here. They're up. I'm going to start, Steve, with you. The first question, I have 2 really that are very close together. So, and the first one is really, how does this work? Is it work by the design engineer, I suppose, uploading the model in the PLM, and aPriori is kind of running up automatically in the background, or does the engineering have to first run the part, cost the part itself, and check in the results in the PLM? So maybe if you want to just clarify that for the audience.
Sure. Yeah, there's actually no need to run the part manually first, as long as, so if you think about the designer working in conjunction with Teamcenter, for example, right? A new part is designed, released, and managed in PLM. As long as that's there and that CAD model is attached to the record in PLM, that can be automatically processed. There's no need for any initial manual interaction or manual costing. I think, as Samantha also talked about with attributes, right? Ideally, if the PLM object contains, your process group, volume, material, that'll automate it and provide the inputs that you need to have that good first pass result. Otherwise, there's fallbacks for the defaults.
And related to that, is it possible to process existing models in the PLM system, or just new models as they come in?
Yes, absolutely. And I think very valuable use case in terms of looking at, different applications, but basically it can be kicked off, and based on a given project, or maybe all parts that are within a specific commodity, a workflow can be triggered to automate the processing of all of those components that fall within, the given criteria that you specify. But it does not need to be on a, as you release and upon a check-in that it happens. It can process existing parts as well.
All right, great, Steve. Samantha, a couple for you that are related. First one is the PLM system need to be in the cloud. Where can it sit? And then also, can you connect to more than one PLM system in the company? I guess either maybe 2 versions of Windchill, or someone who have, let's say, an Ovia and Windchill. Could you comment on that?
Sure. So we support connections with PLM systems both in the cloud and on-premise, so that doesn't matter. And then we support multiple connections to multiple different PLM systems. So if you have more than one instance of the same type or different types, you can use all of those PLM systems and integrate them with CI Connect and CI Generate.
Great. Another question here that maybe I'll take this one. It says, do you need to change the PLM system to support automated costing with CI Generate? And I think, Steve, you were hinting on this a little bit yourself, but first answer is no. We can work with whatever is in the PLM system, but there are ways that you can augment your processes within the PLM environment to better support what CI Generate's trying to do. And Steve was saying that the first thing really is to get a very accurate and informative analysis that shows a good cost data, and as well as manufacturing guidance. There's certain things, the production inputs that we need, like process group, annual volume, things like that, material that can help drive that process. We have numerous places where you can get that from, but the more we can get that data at the source from the PLM system, the easier it is to set that up. The other is just your own internal process and how you're using aPriori. You may have certain UDAs that are important to drive what's going on from a costing perspective, also just the workflow management within aPriori itself. So if you can pull the values from the PLM system to drive the UDA values. The other is just the way Cost Insight Generate would work in CI Connect in particular. It wants to look for parts that need costs. So if you had some attribute that said, yes, this needs an aPriori cost, something like that would help drive that. And then after we do the work of generating that cost and other information. It could be cycle time, it could be a routing, whatever you want to push back to the PLM system. We could update that field with saying yes, and the costing exists now. So helping to manage that kind of workflow, I think, would make things easier from that perspective. Julie, a little bit of time left. Someone wanting to know what the steps are required to use CI Generate, I guess, if you're an existing customer on premise versus maybe an existing customer on cloud. Is there an upgrade process? Maybe you could just comment on that.
Let me touch base on that. So we've been working with the services team to create deployment playbooks and to create a recipe. So there's sort of two different approaches depending on whether you're on the cloud already, and then what we would help you do is upgrade to 2019 R3. We would handle the upgrade behind the scenes, and then using Cost Insight Connect, we would do three things. We would make that connection to your PLM system. We would set up the automated workflows, looking at what are the auto costing, auto analysis workflows that work for your business, whether it be a sourcing use case where you want to take a look at a population of existing parts and cost those, or set up some ongoing analysis for NPI, and then set up the notifications. So Cost Insight Generate brings kind of three more parts to a deployment: the setting up the PLM integration, defining the automated workflows, and defining the automated notifications. For those that are on-premise, there's one additional step, which is to migrate to the cloud. And we do have we've worked with our services team to build a process to do that very efficiently, migrate your database, your VPEs, so all of your existing content and your virtual production environments can be migrated over to the cloud and available in a cloud environment too. And then we would do those steps about setting up the PLM integration, the automated costing, and the automated notifications. Great.
The one very quick question, someone was asking, is there an interactive version of Cost Insight available for designers? And let me try to answer that quickly. Cost Insight Design, which is the application that Steve spent a lot of time in showing, that is an interactive product that a design engineer would work with through a browser. The reporting environment that Steve showed also has interactive ability to build reports. And then the last thing you might have been referring to, because they all start with Cost Insight, so that's design, report, and connect. The application that Samantha was talking about is generally not targeted at a design engineer. That would usually be a deployment lead admin type who would be setting up workflows and everything, but it also is a browser interface and interactive design as well. So we're at the end of our hour. I want to thank everyone for attending.
Thanks for joining us this afternoon. Take care.